So when we have base 10, we count in base 10, and base 10 is useful. It's not the best base, but this is what's stored in our calculator. We do count in base 10, so we want to be able to use a base 10, and we're going to use our calculators to do this, okay, because the calculator has this built in. Now, if I were to estimate a value for 10 to the power x equals 5, well, I know 10 to the power 0 is 1, 10 to the power 1 is 10. So if I were to estimate this, I'd say maybe x is somewhere between 0 and 1, I don't know, 0.5. Okay, so I can test this. I can just test it in my calculator. I can go 10 to the power 0.5, and I get 3.16. So 10 to the power 0.5 is approximately 3.16. So it's probably somewhere bigger than that, maybe 0.6, 0.7, somewhere around there. So I want to actually use a log because my calculator has logs built in. It has and this is a problem. This is when I need my calculator, is when the base 10 and base 5, these are not compatible. Okay, they have to be compatible by powers, not by divisibility. So I need a calculator here, or I need to guess and check. Okay, and I don't want to guess and check. My calculator has this built in. So I can try using my logs on my calculator. So what I'm going to do is I'm going to convert my exponential expression. So my answer y is my output. Okay, so I write it in the log form. And when I have it in the log form, I can then use the logs on my calculator. So that's what I'm going to do here. I'm going to change this to log base 10 of 5 equals x. And I'm going to find that log button, base 10 button on my calculator. Okay? So I'm going to go log, and then my input is my answer of 5, and that's going to give me the exponent on 10 that gives me the number 5, which should be bigger than 0.5, right? It's got to be less than 1, because we know that 1 is going to give us 10. And my calculators give me a value of 0.69897. It's a messy, irrational number, so I'm going to round that to 70. And then I'm going to check that number. So I go 10 to the power 0.70. I get 5.0. Yeah, that's about right. That gives me approximately the right exponent for this problem. So if I want to do logs on my calculator, I want to first of all convert it to log base 10. Okay, so I need to have a base 10 expression, and then I can calculate the exponent. So here, I convert this into base 10 log. The answer is going to be the exponent. The input should be the answer to that exponential expression. And I'm going to type this into my calculator, because unless I have a calculator, I'm going to have to guess at this because the bases are not related. So I'm going to go log base 10 of 20. I get it's approximately equal to 1.30. I'm going to actually give a third decimal here, 1.0301. So that sounds about right, because it's got to be bigger than 1, because 10 to the power 1 is 10. It's got to be less than 2, because 10 to the power 2 is 100. Okay, so somewhere in between. Here I'm going to go log base 10. The argument is 4,000. It's going to equal b. Okay, so I go log base 10. The output 4,000. The exponent I need, I know it's got to be bigger than 3 because it's got to be bigger than 1,000. It's got to be less than 4 because it's got to be less than 10,000 because this is 4,000 in between. So my answer that I should expect is between 3 and 4. And I'm getting here b, my calculator, again it's an irrational number, 3.602. Okay, about. So this is our approximation for that exponent, and we need our calculator here because the bases are unrelated. Okay, and logs is not about your calculator, but if you have unrelated bases, we're going to need some kind of calculating device, or we're going to have to do a lot of guessing and testing to get it right. But the math is in understanding how we go from this expression to this log expression.